All right, we are going to start with homework number 21, and the name of this is inverse functions. And we'll get to the inverse functions in the second half of this lesson. To start off here, we're going to be solving square root and other radical equations. Okay, so we look at number 1. Number 1 tells me to solve. That's what the directions say. Just say solve. And we've been working with radicals as well as square roots over the past few weeks, so this is a bit of a review, but then also adding in some new things, okay? So we have 3 times the square root of x plus 3 equals 15, okay? And we've solved problems like this, similar problems like this before, where if you just take the square root of x, and if you just treat it as if that was just an x, right? And I said, solve this equation. Naturally, what you'd want to do is you'd want to isolate the variable. And in this case, that doesn't change. We still want to figure out what x is equal to. So when it tells us to solve, we want to solve for x, right? So that's what we would do is if we had a variable there that we weren't finding the square root of, if we just had 3x, the first thing we would do is we would subtract 3 from each side, right? Because we want to isolate that variable. But since we're not dealing with just 3x, we're dealing with 3 times the square root of x, we're going to still start off the same way, but in the end, do something differently, okay? So I subtracted 3 from each side because we want to isolate. We want to get x by itself in the end, so we want to get everything else away. Remember, to isolate is by making it by itself, all right? So if I have 3 times the square root of x, and set that equal to 12, okay? Remember, I just said 3 times the square root of x, 3 times. So the opposite of multiplication is division. So I want to divide to get that 3 to the other side. And that leaves me with the square root of x is equal to 4. All right? Now we want to get x by itself. X still isn't by itself. If you get this far and leave it, that's not the correct answer. Okay, I want to isolate x. And the opposite of finding the square root of a number is to square it. So I'm going to go ahead and I'm going to square both sides. Okay, I'm going to raise it to the second power. All right? And by raising it to the second power, I get x is equal to 16. And that is my final answer. Now remember, whenever we find the square root of a number, its opposite is to square it. When I've done that, that just gets rid of everything that's around it and leaves just the x. And that's how that x got down there by itself. Okay? So I've went ahead and solved this problem. The next few will be similar, but we're going to walk through those as well. All right, let's get some practice in. Number 2, we have 4 times the square root of x minus 1 equals 3. All right, we're going to follow the same steps as before. Remember, the first thing we did was we wanted to go ahead and add or subtract whatever's tacked on the end there to the other side. So that leaves me 4 times the square root of x is equal to 3 plus 1, which is 4. All right. Now I have 4 times the square root of x. That's not the fourth root of x. If it was the fourth root of x, there'd be like a 4 inside that check mark. It's not there. All right, it's on the outside. So 4 times, which means 4, you're using multiplication, okay? In this case, the opposite of multiplication is division. So I'm dividing by 4 on each side. And I get the square root of x is equal to 1. Okay, and then to this square root symbol here, we want to get rid of that. So let's square each side. And I get x is equal to 1 times 1, which is still 1. All right, and my answer for number 2 is x equals 1. Right, very similar to our first example, right? Let's still do one more, right? Let's do number 3. All right, number 3. Number 3 is the square root of 2x minus 1. Notice all of this is inside the radical, okay? The square root of 2x minus 1 is equal to 3, okay? Now, the same way that when I look at this radical, it's covered. Notice that this top part of the radical symbol covers all the way over the minus 1. If it just looked like this, that would be an entirely different problem, right? That would be an entirely different problem because the symbol does not extend over that negative 1. In our last example, we would have just added 1 to each side and solved like that. But that's not the case in this problem, okay? What I want to do is, to start this off, I want to get rid of this radical symbol because that's how I access the information on the inside. So I'm going to go ahead and square this first, okay, so I can get inside of that radical symbol. That will then get rid of it for me as well. So if I take 2x minus 1 is equal to 3 squared, which is 9. All right. Now from here, I can add 1 on each side, and I get 2x is equal to 10, and then divide each side by 2, and I get x is equal to 5. Okay? So just to show you what I did, all right, I first squared everything up at the very top. I squared both sides, and that allowed me to get rid of the radical symbol, and that allowed me to start here. And then once I did that, I want to isolate x still. The goal in all of this, the goal is to isolate x, or the variable, whatever the variable's name is, okay? So once I've done that, I get x equal to 5. Now let's just check it. We didn't check the other ones, but let's check it to make sure. Remember, the original problem was the square root of 2x minus 1 is equal to 3, right? Let's check this and just make sure, okay? We found that x was equal to 5, right? That was what we said. Whoops. That's what we said right here, okay? So I'm going to go ahead and write this. Let's see if this is true. Okay, the square root of 2 times 5 is 10 minus 1 is equal to 3. The square root of 9 is equal to 3. What's the square root of 9? The square root of 9 is 3. Is 3 equal to 3? Yeah, 3 is equal to 3. So this must be my right answer. X must be equal to 5. All right. All right, number 4. Number 4 says, it still tells me just to solve, and I have x plus 5 raised to the power of 2 over 3, and set that equal to 4. All right, so I'm going to write out a few steps here that I'm going to take, and they may not make sense right away. I'm just going to write these steps out. We'll follow these steps, and then we'll look back at them and see how they were true. All right, so the first thing I'm going to do in order to solve a problem like this is I'm going to multiply my exponents on each side by their reciprocal. Okay, that's the first step. I'm just going to keep going with the steps, like I said, and then we'll eventually use them. The second step is that we're going to check the exponent, and if the numerator or denominator is even, then find the absolute value of x. All right, my third step is that I'm going to set my denominator, or my denominator is actually going to be the index value. Okay, and my numerator is actually going to be the power, or the exponent. All right. And then from there, we're going to simplify the radical. All right. After that, we're going to split the absolute value. And we're going to split it two ways with a negative answer and a positive answer. And the sixth thing we're going to do is we're going to solve whatever's left. All right, so these are my 6 steps in order to solve these next 3 problems. All right, so let's take a look at this. Let's go down each of the steps, 1 through 6. I like making lists, and this is just the easiest way that I can go through and just follow these directions. All right, so my first step is to multiply the exponents on each side by its reciprocal. All right, so really, this is 4 to the first power, right? Or 4 to 1 over 1, if I really write it that way, but I don't have to. All right, so we're going to multiply the exponents on each side by the reciprocal. All right, so 3 over 2, if we do it to one side, we have to do it to the other, 3 over 2. What that allows me to do is anything, I guess I can write 2 over 3 times 3 over 2 gives me 6 over 6, which is the same as 1, right? And if I have x plus 5 to the first power, that's just x plus 5. So what that allows me to do is rewrite this. X plus 5 is equal to 4 raised to the power of 3 over 2. All right, so we completed step 1 there. Okay, now for step 2, it says check the exponents. And I'm looking right here. Okay, if the numerator or denominator is even, if the top up here or down here, if either of them are even, then find the absolute value of x. All right, so I know that 2 right there is even, so that means I'm going to have to find the absolute value of x plus 5. All right, so I've done that. Now, I need to rewrite this right here. I need to rewrite it where my denominator down here is my index, and whatever's in the numerator is going to be my exponent. We did this in previous weeks. So I'll rewrite this. Absolute value of x plus 5 is equal to the square root of 4 raised to the third power. All right? And I've went ahead and completed step 3. Now I want to simplify my radical. Let's go ahead and do that. So I'll rewrite this side. I feel like that line's getting more and more diagonal. Let me help fix that. Here we go. All right, 4 to the third power is 64. Okay, and then the square root of 64 is 8. All right, so I went ahead and did that. Now, it says split my absolute value 2 ways with a negative and positive answer. So I could write this as x plus 5 is equal to 8, and x plus 5 is equal to negative 8. We've done this in previous lessons. When we've talked about absolute value, when we get down to this step, we would break it 2 ways, and there would be 2 answers, right? So I have x is equal to 3, and I have x is equal to negative 13. All right? And I was able to solve this problem and find my two answers. All right, number 5. Number 5, I have x plus 2 raised to the power of 2/3 and set that equal to 9. All right, and we're asked to solve this. Okay, so the first thing I'm going to do is I'm going to multiply this side by 3/2 and this side's exponent by 3/2. Okay, what that gives me is x plus 2 equals 9 raised to the power of 3/2. All right, is a number in the numerator or denominator even? This number right here is even. So that means I have to find the absolute value of x plus 2. All right, and then I'm going to rewrite what's on the right over there. I'm going to find the square root of 9 to the 3rd power. And if I have x plus 2, 9 to the 3rd power is 729. So the square root of 729. All right. And the square root of 729 is equal to 27. All right. Now I've gotten this far. I'm going to break it two ways, one with a positive answer and one with a negative answer. I'm going to subtract 2 from this side, and I get x is equal to 25. And then I'm going to subtract 2 from this side, and I get x is equal to negative 29. All right? And those are my answers. And that's number 5. Doing one more, let's move to number 6. All right? Number 6 is quantity of x plus 1 raised to the power of 3/2 minus 2 equals 25. All right. So the first thing I'm going to do is this 2 is in the way. So I'm going to go ahead and add it to the other side to get to where we started before, right? Okay, I'm going to multiply by its reciprocal. Okay, and I get x plus 1 is equal to 27 raised to the 2/3 power. The numerator up there is even, which means I'm going to have to find the absolute value of x plus 1 and write it like this. Okay, that 2 is really big. And then I want to simplify what's on the right over there. So I'd find the cubed root of 27 squared. And 27 squared is 27 times 27. And that gives me 729. Okay, and let's do the cube root of 729 gives me 9. X plus 1 is equal to 9. And then once I get here, I'm going to break this two ways. I have x plus 1 is equal to 9, and x plus 1 is equal to negative 9. Subtract 1 from each side, and I get x equal to 8. Subtract 1 from each side, and I get x is also equal to negative 10. And that's my answer for number 6. All right, moving on to number 7. Okay, now number 7, the directions now ask me to check for extraneous solutions. Okay, what that means is once I get my answers, I want to check and make sure that these answers work. Check my work. So an extraneous solution is a solution, and I guess I'll write this out. Extraneous. I remember when I first learned about extraneous solutions, and I was like, wait, so like everything I've learned has been a lie. Extraneous solutions are like when you're done a problem and you get the solution, and like you've done everything correctly, all the steps your teacher told you, and you get all the way to the end, and then you check your work and it's not right. And I remember the first time I didn't like pay attention to my teacher when we were talking about extraneous solutions. I went and checked my work and it was wrong, and I couldn't figure out what I did wrong, and I didn't do anything wrong. It's just in math, when you're dealing with conversion between square roots and then back to exponents and back and forth, sometimes we mess up. Sometimes math doesn't account for certain situations, and we just have to check our work. And there are things called extraneous solutions. And an extraneous solution means that we solved everything, we got an answer, but it just isn't true. And I'll show you what I mean by this. Okay, number 7. Number 7 is a good example to start with. Okay, so I have the square root of 3x plus 7 equals x minus 1. Okay? And the first thing that I'm going to do here is I want to access what's inside of this radical on the left. So I'm going to raise each side to the power of 2. Okay, that will at least allow me to rewrite it the left side like that. On the right side, I just keep it like that, which is also the same as x minus 1 times x minus 1. All right, if we write it out like that. Now, we can use the box method to work on the right side over there. I have x minus 1 and x minus 1. X times x is x squared. I get a negative x there, a negative x there, a negative 1 times negative 1 is a positive 1. Okay, so I get x squared minus 2x plus 1. So I'll go ahead and rewrite that. Oops. X squared minus 2x. Whoops. Plus 1. And then rewrite what's on the left over there. Okay. And now once I'm done that, I want to get everything on one side of the equation. So I'm going to subtract 7 from this side first. And that will give me 3x is equal to x squared minus 2x. 1 minus 7 is negative 6. And I'm going to subtract 3x. I'm going to get everything on one side. I don't want, like if I'm solving here, I want to make sure that we are getting all the x's on one side. So I get 0 is equal to x squared minus 5x minus 6. All right. And once I've done that, right, I can use the box method. Okay, my factors of 6 that I have are 1, 2, 3, and 6. This is all a review from here, right? If we're looking to solve this, a minus minus means that my answer is going to be a minus plus, okay? And we want to still keep that and set equal to 0. So I know I have a minus plus. I'm going to try x and x, and then I'll use negative 6 and 1. I know normally I try the middle two first, 2 and 3, but I just did that work in my head and realized it wasn't going to work. So x times x is x squared. X times negative 6 is negative 6x. And I get negative 6 there. So like I said, normally I start with 2 and 3. I could have written that out and showed you it didn't work, and you can write it out and see that it doesn't work. I just did it in my head really quickly and realized it doesn't, so I moved on to the next one. And what I get is x squared minus 6x plus x minus 6. That gives me x squared minus 5x minus 6. Is that the same as what we started with? The answer is yes. So I know I have x minus 6 and x plus 1. And remember, that's just x minus 6 right there and x plus 1 over there. Okay, now I go ahead and solve for each. So I say x minus 6 is equal to 0, and then x plus 1 is equal to 0. I add 6 to both sides, and I get x is equal to 6, and then subtract 1 from each side, and I get x is equal to negative 1. Cool. Now, I went ahead and solved this problem. Okay, normally I would just circle both and say, there we go, we did it. But it says check for extraneous solutions. And extraneous solutions, once again, are solutions that don't work when you go ahead and check your work. And those aren't actually solutions at all, right? And I can cross it out afterwards. So here's what I'm going to do. Let's just try for, let's try for 6, all right? So I'll have the square root of 3 times 6 plus 7, that's what we started with, right, is equal to x minus 1. All right, that was our original problem. I substituted 6 back in, which means I should also substitute 6 in right here. All right, and let's make sure of this. 6 times 3 is 18. Okay, 18 plus 5 gives me 25. 6 minus 1. So square root of 25 is 5. 6 minus 1 is 5. Is 5 equal to 5? Yes. So x equals 6 works, right? I've checked it, right? I checked my work, it works. Now let's try negative 1. All right, watch this. So if I have 3 times negative 1 plus 7 and set that equal to negative 1 minus 1, which is really just what we started with, the problem, substituting the value back into the original problem. And I have the square root of negative 3 plus 7 is equal to negative 1 minus 1 gives me a negative 2. The square root of 4 is equal to negative 2. The square root of 4 gives me 2. Is 2 equal to negative 2? And the answer is no, it's not. Which means that this other solution, x equals negative 1, that's an extraneous solution. Okay, so it's not true. So I know x equals 6 works and solves the problem, but x equals negative 1, even though we got down to the very end there and we saw it as a solution and we didn't do anything wrong, it's not a solution that works. We just saw that 2 is not equal to negative 2, so it doesn't work. It's considered an extraneous solution. All right, and that's number 7. All right, let's move on to number 8. Number 8, I have the square root of x plus 7 minus 5 equals x. All right, and my first step is I'm going to want to add 5 to each side here, and I get the square root of x plus 7 equals x plus 5. All right, in order to get rid of this square root, I'm going to square each side. And when I square each side, I get x plus 7 is equal to x plus 5 times x plus 5. I'm going to use my box method to multiply these two together. X 5, x plus 5, x squared, 5x, 5x, 25, x squared plus 10x plus 25, x plus 7 is equal to x squared plus 10x plus 25. I want to get one side equal to 0, so I want all the variables on one side. So I'm going to subtract x from each side, and then also subtract 7 from each side. So I get 0 on the left. I get x squared. 10x minus x equals 9x. 25 minus 7 gives me 18. All right. Once I've done this, I want to go ahead and look for my answer here. I'm going to set 0 equal to, I know my answer is going to be a plus plus because I'm dealing with a plus plus. And let's try out a few potential answers. First, I want to look at the factors of 18. The factors of 18 are 1, 18, 2, and 9, 3, and 6. All right, I like to try the two middle ones at first. So I'm going to try 3 and 6. All right, let's try that. X, 3, x, 6, x squared, 3x, 6x, 18, x squared plus 9x plus 18. Is that what we started with in the very beginning? Yes, so I know my answers must be x plus 3, which is right here, and x plus 6, which is right here. All right, once I got down to there, I'm going to go ahead and set each one of these equal to 0, x plus 3 equal to 0, and x plus 6 equals 0. Subtract 3 from each side, and I get x is equal to negative 3. Subtract 6 from each side, and I get x is equal to negative 6. All right, so these are my two possible solutions. All right, let's check and see if we have any extraneous solutions. So I have negative 3 and negative 6 are my possible answers. All right, so negative 3, x equals negative 3, or x is equal to negative 6. My original problem was the square root of x plus 7 minus 5 equals x. All right, so let's test this out. All right, so let's try negative 3 first. The square root of negative 3 plus 7 minus 5 is equal to negative 3. The square root of negative 3 plus 7 gives me 4. Minus 5 is equal to negative 3. The square root of 4 is 2. 2 minus 5 is equal to negative 3. Negative 3 is equal to negative 3. Is that true? Yes. So I know that negative 3 is a solution. All right, let's try the other one. So once again, this was my original problem right here. So I'm going to put negative 6 in for x. So I'll say negative 6 plus 7 minus 5 equals negative 6. Negative 6 plus 7 gives me the square root of 1. Okay, the square root of 1 is still 1. So 1 minus 5 equals negative 6. 1 minus 5 gives me negative 4. Okay, is negative 4 equal to negative 6? The answer is no, it is not. So I know that this is an extraneous solution. So we know that x equals negative 6 cannot be a solution. That's an extraneous solution. All right. And that is number 8. number 9. Okay, number 9, we're going to start talking about function operations, and we'll learn a little bit about addition, subtraction, multiplication, division. We'll do more of this for weeks to come, but I at least wanted to start off. All right, so for each of these problems, for 9, 10, 11, and 12, I know that f of x is going to equal 7x plus 5, and g of x is going to equal x squared. Okay, so it says f plus, number 9, is f plus g of x. And what this means is I'm just going to add the two together. I'm going to add f of x, which is 7x plus 5. I'm going to add that to g of x, which is just x squared. So really, if I rewrite this in standard form, I get x squared plus 7x plus 5. All right? And that's my answer. That's all I needed to do, is just show I'm able to combine those two. As well as if I were to subtract f of x minus g of x, okay, I have 7x plus 5 minus x squared. I guess I can put that inside parentheses, right? So now if I were to write this in standard form, I could say negative x squared plus 7x plus 5. And I'm done. Number 11, we'll multiply f of x. So 7x plus 5, multiply that by g of x, which is x squared. All right, so now what I would do here is, knowing that I'm using multiplication the same way that like 3 times 4 is the same as 4 times 3, I'm just going to rewrite this, right? X squared times 7x plus 5, okay? And I'm going to use distributive property and multiply these two together and then multiply these two together. So x squared times 7x gives me 7x to the third power. And then 5 times x squared gives me 5x squared. And that's it. That's my answer. Number 12. I have f of x divided by g of x, so I get 7x plus 5 over x squared. And I can just leave it like that. That's all I have to do. Now, there's nothing further that I can do in this example. So number 12 just says f of x over g of x. I'm just substituting those values in. That's as far as I can go. I cannot go any further than that. Okay? And that's it. All right, number 13. Number 13 asks me to find the inverse of each relation and to graph the given relation and its inverse. So it gives me this xy table here. And I have 1, 2, 3, and 4. As my x values. And in my y values, I have 0, 1, 0, and 2. Okay? So that's what I have. And it says find the inverse. For an inverse, all I'm doing is swapping my x and y values. Okay? So this is called the given relation. And it's inverse. So it's inverse. In order to find that, I'm just going to swap my x and y values. Okay, so if I had 1, 0, the inverse would be 0, 1. If I had 2, 1, the inverse would be 1, 2. 0, 3, 2, 4. I'll just flip-flop them, okay? And now it wants me to graph both. All right, I'm gonna have to plug this in here because it looks like it's dying pretty quickly. So let me go ahead and plug this in. There we go. Okay, so what I'm going to do is I'm going to graph this. Let me make this line straight. All right, so I have 1 and 2. All right, this is my y-axis. This is my x-axis. And I'm graphing my given relation, which is on the left here. I have 1, 0. I have 2, 1. I have 3, 0. And I have 4, 3, 0, and 4, 2. 1, 2, 3, 4, 2. Okay? It's my given relation. So I don't know what this looks like past here, but it looks like just based off of this trend that I got something moving like this. All right? And this was my given relation. So I'll just say GR. How about that? GR. And then its inverse, let's graph that one. 0, 1. And 1, 2. And 0, 3. 1, 2, 3. And 2, 4. 1, 2, up 4. So I get something that kind of looks like this, right? Right, and that is its inverse. I'm not given an equation or anything like that, so I don't know what it's supposed to look like, but that's what I've graphed. I've graphed not only the given relation, the table that it gives me, but then I've also graphed its inverse, okay? That's number 13. That's all it's asking me to do for 13. Number 14 is very similar to that. Okay, number 14, I have my x and y. I have 1, 2, 3, and 4, and 0, 1, 2, and 3. All right, and this is my given relation. And let's go ahead and find its inverse. Okay, so I have x and y. Whoops. And the opposite of 1, 0, its inverse would be 0, 1. 2, 1, so I'll do 1, 2. 3, 2 gives me 2, 3. And 4, 3, 3, 4. All right, let's graph these. So there's my y-axis. There's my x. Let me label them. Make sure you put arrows on the ends because they move on forever in that direction. There's my x. There's my y. We'll start with the given relation on the left over here. So I'll do 1, 0, 2, 1, 3, 2, 4, 3. All right, and the line, it looks like a linear function, right? Looks like, I don't like that. Let's start over here a little more, right? And I'll make this, there you go. All right, and that is my given relation, my GR. And then let me graph the inverse. 0, 1, 1, 2, 2, 3, and 3, 4. That's kind of ugly. All right, and if I were to graph it, that's not a good line. Let me try and draw a line that goes through as many of this as possible there. There we go. And there is my inverse. It's not pretty, okay? It's not perfect. I make mistakes when I'm doing this. But there is my inverse. All right, that's number 14. Number 15, it says find the inverse of each function is the inverse of function, and then graph it in your graphing calculator. Okay, and the first thing I'm going to do is I'm going to find the inverse of each function. And number 15, it gives me a function. It says y is equal to 3x plus 1. Okay, and what I would do is, in order to find the inverse, I just swap my x and y values. So in order to find the inverse, I'm going to swap x and y. Okay, so to start this off, I'll say x is equal to 3y plus 1. And then, after I've swapped, so I'll say step 1, swap x and y. And step 2 is solve for y. Okay, so I'm going to subtract 1 from each side here. I get x minus 1 is equal to 3y, and then divide each side by 3, and I get y is equal to, well, I guess I'll write it like this. I'll say y is equal to 1/3 x minus 1/3. Okay. And the way I did that, so if you're wondering, how did you do that? I just know that there's a 1 out in front of x there, and that's the same as writing 1x over 3 minus 1/3, and then the final step is I just put that x on the outside, like that. Okay, that's how I did that. And that's its inverse. And the question it asks is the inverse a function at the very end? And it's to graph it on your graphing calculator. Okay, so for you then, what you would do is you would type this into your graphing calculator. Y is equal to 1/3 x. And when you're writing this in your graphing calculator, you're going to go to the y equals, and whoops, it looks like this. You're going to put parentheses, you're going to write 1, and you write slash, and you write 3, and you're going to close parentheses, and then write x, the xt theta n button. Then you're going to write minus, and then parentheses 1/3. All right, then you'll graph it. And you can tell if it's a function, so how do I know whether or not it's a function? You can tell it's a function by using the vertical line test. So like, for example, if I were to graph, it looks like this. If I were to draw a vertical line through it, and it only goes through 1 point gives you a function. Okay, but if I have more than 1 point, so I don't know, let's say I go and I graph, and it looks something like that, right? And I do the vertical line test. Notice how it goes through 2 points, right? So more than 1 point is not a function. Okay? In this case, number 15, that's going to give you a function, right? You're going to have a function. Number 16. Number 16, I get y is equal to 2x minus 1. First step, swap. Second step, solve for y. Add 1 to each side. I get x plus 1 is equal to 2y. Divide each side by 2. And I get y is equal to 1/2 x plus 1/2. Graph it. Is it a function? The answer is yes, it's a function. That's my answer.